Okay, 12.3. We got 4 topics, one more topics. 12.3, Gauss's law. Right, very simple. State the law. Apply it to derive electric field for isolated point charges, isolated charge conducting sphere, uniformly charged plate. Okay, let's do that. Page 9 in your book, can just refer to your book there. Gauss law. Okay, there's your area, surface, right? Surface area A. There's the electric field coming out perpendicular to the surface. So we want to define a new term, electric flux. Number 1 in your book.
One question. Why the arrow like that? Answer. Why not like perpendicular means like
Perpendicular, that's how I can't draw it perpendicular. Right? You have to draw it, so that's how I have to draw it. That's how it's gone perpendicular. You have to imagine it. Okay, no? You have to imagine it. It's perpendicular to the surface.
No. What I mean is why the line never draw straight line. That's why I'm wondering.
How to draw a straight line? The cut is this surface area is slanting. That's why I have to put slanting. So you just have to imagine.
Surface area slanting. Okay.
You have to imagine it's slanting. That's all. Imagine it's 90 degrees. So they define.
But they never mention slanting. But if we keep it straight,
no, you have to learn to imagine. Cannot draw everything perfect for you. This 2 dimension is 3 dimension. So you have to imagine.
I'm just asking. So by right, you can also do straight
you can
one
draw.
also, right?
You can draw perpendicular if you want to. If you can draw that.
A straight perpendicular lah.
You want to do 2 dimensions? Yes.
Just asking.
But you are going to do 3 dimensions, so you have no choice. You have to slant it a little bit. So it's defined as the product of electric field strength E. That's your E. And that's perpendicular to the surface and area of the surface. Right? E times A. Right? E perpendicular to the surface area. Unit E is volt per meter. A is meter square. So you just cancel that, you get volt meter. Or if you use Newton per Coulomb times your meter square, then there's the alternative unit. Symbol, we call it phi. And you can visualize flux as the number of lines passing through this area. That's all.
Wait, phi is that zero, that zero with the cross, right? Basically.
Huh? What is zero?
No, the Greek symbol phi.
Yeah. It's just a Greek alphabet.
Yeah, I mean the one beside the EA. That's that one, right?
Yeah. Let's call your phi. Let's call your phi. Greek alphabet. A circle with a stroke.
Can be visualized as the number of field lines passing through the area.
Yeah, it's a scalar quantity.
So I mean this one involves the what's that? It has to involve surface area and electric field strength. That's it lah.
Yeah. You have to learn. Physics is just like learning English. You define new term. You have to learn how to apply the new term. Make sentence. So same with physics. You have to learn the definition first before you can go and do research. All the definition.
Okay.
Right? So if it's not 90 degrees, remember this line is 90 to the surface. Just imagine, that's all. And then if it's at an angle theta, E is at an angle. Right? This one is the normal. That's your surface with area A, same. Right? Normal is 90 degrees to the surface. If E is at an angle, we want the perpendicular component, remember? Electric field EP is your perpendicular component of electric field. Theta is the angle between the electric field and the normal. Then we resolve it. Resolve E in the perpendicular, in the normal direction. So E cos theta. So EA cos theta is a scalar quantity. Okay. Yep.
Oh yeah, it's not a vector because you don't know the direction. But
Basically, you go to university, they will tell you that A is a vector. The direction is normal, direction of the normal. Right? Direction of A is perpendicular to the surface or along the normal line. That's A. That's the reason why vector times vector is a scalar.
yeah, vector times vector can either be a scalar or vector, depends, right?
In this case, is a scalar product.
How you know it's a scalar? Huh?
Just memorize only. We don't want to go into more detail than that. There's a test.
Oh yeah, first time, yeah lah. I remember they told like vector times vector can be still scalar lah. Right.
Vector times vector can be vector. In this case, it's a scalar product. Right? So A is usually considered a vector. Direction, normal to the surface. That's your A, pointing outwards. Okay, if you want, you can draw it this way, if you prefer. Right? Usually, we will represent your flux as that. This means a closed surface. A closed surface, E times your dA. dA is just a small area. This is a small area on the surface. Right? That circle.
Okay, okay. So before that means this electric flux, the thing has to always be slanting lah, basically.
It doesn't matter. You must know how to calculate. That's all. If it's not, it's at an angle, then you have to use cos theta. That's all. And remember that your E is at an angle to the normal. That's all. That theta is the angle to the normal. Right? So this is an integral over a closed surface. T is closed surface. dA is just a small area. Right? And the vector is normal. That is a vector for A. Right? Or normal. Okay with that? So we define the first concept, flux, electric flux. Yep. If it's okay, we go further.
Okay.
No choice, you have to learn to master the term. That's why I have to ask you to work and work and work to force it in. If not, you'll find it difficult. Gauss law states that
better you force me lah.
The electric flux through a closed surface is given by flux. Right? That one is sum of charge. This is your permittivity of free space. Right? This is the sum of charge or algebraic sum of the charge enclosed by the surface. That means the charge that's inside the surface. Remember, it's a volume. It's 3 dimension. It's a volume surface area of a volume. Dalam permittivity of free space, vacuum. Okay, memory work, nothing much. Understand the term, what does it mean? Yeah, next part we are going to use Gauss law.
Wait, the electric flux through a closed surface given by algebraic sum divide with vacuum. Why divide with vacuum?
It's just a memory work. You have to learn to define the term. That's how the law is defined.
So just
memorize it. Nothing much. You have to memorize the law and use it. Cannot go and ask the textbook why it's defined that way. The scientists define this way, so you have to learn it to define this way.
Accept lah.
Accept it.
Okay.
Just like you have to accept area is pi r squared.
Oh yeah.
Okay. Yeah, these are things you have to learn to accept the definition. Right? Absolutely not, as I say, we have given you the value. Okay, what's the answer for this one? Page 32, number 7.
Page 32, number 7.
Yeah, in your book.
Okay.
Using what we have just learned.
Page 32, number 7. The electric flux. So this one we use Gauss's law, is it?
Yeah. Just that.
Okay.
Gauss's law.
1 minute. Don't show me the answer. I'm gonna try first. Okay. The sum is algebraic sum is the algebraic sum is plus 2q. That's the only thing they have. And then epsilon you just substitute only, right?
Yeah, epsilon, the value is given.
So the radius no need to care.
Don't need to worry about the radius. If you are not using it, unless you want to find the electric field strength. Not everything given is to be used. Sometimes it's just a distraction.
I mean, to see how much we understand lah.
Yeah.
The answer is 2.26 times 10 to the power 11.
Yeah. Good.
Yes. Okay. Oh, like that.
That's why I say you have to do the question, then you can know how to apply it.
Effort.
No shortcut. No shortcut. Right? Learning.
Sure, I think the SEM 2 is going to be the hardest semester because you got so many things to do.
Don't think of it hardest. Think of it as you have to overcome it. That's all.
I think I use this as my chance lah, because then later
Challenges.
in university.
See, as challenges in life. University also will push you to do a lot of things. So these are
So
challenges.
I will take this as a chance to prepare for university lah.
Yeah. Life is like that. A lot of stress. You have to overcome it, not give up.
Sure, but the good thing is, right,
Yeah.
Sure. Next year is the SEM 3 paper, I think end of March. But the good thing is usually they'll ask us to retake like after the SEM 3, for the SEM 1 exam or SEM 2. But then this time the SEM 1 paper is early, very early.
Okay, I hope you don't have to retake.
No, but you do know, right? This time the paper very early, like 2 months after the SEM 2 exam finish. Like very early this time.
It's okay, wow.
Oh yeah, at least
you got 6 months to prepare.
During SEM 3.
6 months to prepare. As I told you, you have not been putting in the effort the first semester. That's why I have to scold you every time. Didn't do your work.
Yeah.
Okay, let's carry on. Right now we want to apply the law. Right, to determine this equation. You have a charge there. That's the few lines. So a positive charge Q at a distance r away. Right? In this case, we have to choose a closed surface where the electric field, we choose it convenient. Gaussian surface, we choose it convenient. Right? So we choose at a radius r a sphere because all the electric field are perpendicular to the sphere as they come out. So the total charge within the Gaussian surface in this case is a sphere. So the total charge within the sphere is just Q. Right? And you calculate the charge, the flux is your electric field times your area. Memorize the it's perpendicular. So it's E times A. Okay, so far?
Just 1 minute, choose a
So
choose a
choose a surface that's perpendicular to the electric field. The easiest surface, you can choose a square. The square will make life difficult for you.
Square?
Yeah. Square or rectangle will be too messy calculation, so you have to choose a sphere. Then
you mean which shape lah?
It must be a closed surface. So surface area A is 4 pi r square. Okay, surface area of the sphere. Okay now. Page 11, number 1.
Page
Nothing much,
11,
we are
number
just
1.
using Gauss's law. First choose a Gaussian surface. In this case, we choose it as a sphere
Yeah, sphere.
because the electric field are all perpendicular to the sphere. That's all. Easy to calculate. So the flux is just E times A because the field is perpendicular to the surface everywhere. Yep. So surface area A is just pi r square. Memory work. Surface area of a sphere is 4 pi r square.
Oh yeah, because it's a sphere, that's why.
Yeah, it's applying Gauss's law, that's all. Right? We are going to apply Gauss's law throughout, that's all. Nothing much.
That means the electric flux formula lah.
Yeah. So we
Yeah,
calculate
will
electric
there be
flux
one?
first.
I wanted to ask, will there be at one point where they'll ask you to combine the electric flux calculation and Gauss's law calculation?
Yeah, we are going to do that. We are going to apply Gauss's law. Teach you how to apply Gauss's law. So first stage is to calculate the electric flux. Choose a surface, calculate the electric flux, EA. Then the next stage is, that's how we calculate EA. Then applying Gauss's law. Right? This is Gauss's law. Flux is sum of charge within the surface divided by epsilon naught. So sum of charge is Q, epsilon naught, and then your E.
We know the epsilon naught lah.
Is E 4 pi r square. And take the 4 pi r square across as well. Take it down. Then we get our answer. So you have to memorize and know how to use this formula.
So I mean the pi and the epsilon are all constant, so we can remove that out, right? No.
Take it down. Not remove it. Take it
No,
down.
I'm
Cross multiply to find E. We are just showing you how to derive the electric field formula, that's all, using Gauss's law.
Oh yeah, so you basically following the MPM lah, what the syllabus they put there.
Okay, we are just deriving the electric field strength formula for charge Q at a distance r away using Gauss's law, that's all. Okay.
Okay.
Then the next part is to show that Gauss's law is consistent with Coulomb's law. Page 11, number 2. There's your Coulomb's law. Right? It means that you can derive Coulomb's law from Gauss's law, that's all. Right? They don't contradict each other. So Gauss's law basically tell you there's a charge there. Right? There's a charge there, Q. And then you place another test charge there, Q, at a distance r away. Right? So the electric field due to this charge there, Q. Sorry, I better put it down there. Okay, there's a charge there. Right? There's a charge there. Right? So there's a charge there. At a distance.
Oh, you can derive Coulomb law from Gauss's law also lah.
Yeah, that's what we are trying to do. Right? So at a distance r away, there's the electric field due to this charge. So now I'm placing a test charge there, small q. Right? So if I put a test charge there, then I know that I use my definition. Force is E times Q. So that is my E. And that's my Q. That's all. So I get my Coulomb's law. Yeah. What's the problem?
Wait, okay, the Coulomb law is basically FQQ over that. So, but then our Gauss's law is the pi equals to the absolute sum divided with the epsilon, right?
This is your electric field strength for this charge there at a distance r away. I just put a test charge there. Right? Test charge small q. Then to find the force, I just take this test charge times the force on the test charge, that's all. Force is just your E times Q. So E is here. This is your E. And that's your small q.
Oh, so you just substitute lah.
Yeah, just substitute, that's all. Applying Gauss's law. Yeah, first thing I have a fixed charge Q. There's electric field strength at distance r away. Right? So to find Coulomb's law, I have to put another charge there. Coulomb's law is 2 charge. Another small charge there, Q there. So if I got electric field, I place a charge there, then I multiply that will give me the force. That's what it's doing. So I replace this E with that value there that I have derived earlier. Yep, what's the problem?
Oh, okay, go on, sir. I'm just like kind of still confused, like I need to adjust first lah.
No choice. Right? There are new terms there, new concept. You have to do the question to understand it. You don't do it, you will lose it. Then you see star, you will lost.
I always wonder, how did you manage to survive, sir?
I didn't survive. I do badly.
No,
Because I
but
was like
then
you.
still after that, you still how you managed to
My form
go on,
6,
sir?
form 6 was a struggle because my teacher was bad. He let us copy notes. And then he
Sir, my
disappeared.
physics teacher also not so good, sir.
But you are trained to trust revision book and model answer for past year paper. Whereas I am lost because I trust my teacher. I don't trust the revision book and the model answer. And then the teacher is not helpful. Don't want to answer question. After writing notes, he disappeared. So I expect you to read the notes and then go to textbook and answer question. So I don't know how to answer. So I don't know how to find help. That's my problem. Don't know how to answer that, can know that I will do badly. So when I study in university, I struggle because my physics is weak. First year was easy because I've studied all this before. So it was easy. Second year was a struggle because my physics foundation is poor. So when I come to teach, I have to learn all over again. Yeah.
But you took the effort and learned, sir.
Yeah, no choice. You want to teach, you don't teach how to teach if you don't know. So like you are teaching you, I have to learn through the new area that I haven't taught before. Right? Your syllabus is slightly different from A level. So I have to learn again. That's why I'm doing all the questions to understand it. And I find your revision book is quite helpful. Of course, there are mistakes here and there, but you don't have perfecting one. Everything must know there's imperfection there. Okay. Now we look at a charge, a solid conducting sphere. Right? Inside there, if we put positive charge inside the solid in the sphere, they will repel each other because they want to be as far away from each other as possible. So the only way is the charge to be on the surface of the sphere. That's where they can be as far as possible from each other. Okay. That's the first concept you have to accept. They have to be on the surface because that is where they are as far away from each other as possible. They won't be inside the sphere. No charge inside the sphere. Yep. All on the surface. Right? So if all the surface, remember the electric field line leave the surface perpendicular to the surface. That means it come out from the center at a radius along the radial line. Right? So it come out, the electric field line appear as if it's coming from the center. Because you just imagine that all the charge is at the center. So if the total charge is on the sphere is Q, right? If we look inside there, inside the sphere, no charge there, right? All the charge is on the surface. So there's no flux there. If we take a Gaussian spherical surface inside a conductor, right? We took a sphere because it's a spherical surface. So
How
inside
is
there,
there inside the sphere no charges?
no charges there, so no flux. Oh.
No, but surrounding there got positive.
We don't worry about, we are looking inside, so don't concentrate inside. We are not concentrating outside, we are concentrating inside. So electric field is going outwards, not inwards. Okay. So no electric field inside, no charge inside.
Oh, you mean that small circle there inside?
Small circle is what we take. We want a Gaussian surface. We want to find the flux inside the sphere. So we take a spherical Gaussian surface. So there's no flux there because there's no charge there. So the electric field is zero inside. Right? They cannot have electric field. If you have electric field means the charge will be moving. Right? Cannot have electric field. The charge is stationary. It's not moving at all. So it must be on the surface. Yep. Okay or not?
Okay, go on, sir.
Right? Now we look outside. Okay, so we have to change to another zoom soon. Right? Same. The charge is evenly distributed. Total charge is Q. So we take a Gaussian surface, a sphere, outside the sphere. Right? Distance R, radius of the sphere is R. That's your new Gaussian surface. Because you are working with a sphere, we take sphere easier because the electric field is all perpendicular to the surface. Right? And we calculate flux first. The first thing to calculate before we use Gaussian's law is to calculate the flux first. So it's E times A. Right? Your E is perpendicular to A. So A is your 4 pi R square, which is your surface area of the sphere. So the total charge in the sphere is Q. Okay, so far, anything not clear?
Wait, the total charge in the what?
Total charge within the spherical, we are now using the Gaussian surface. This is the red one. So the total charge inside this Gaussian spherical surface is Q. That's what it is. The total charge is Q inside the sphere.
Total charge around the Gaussian surface is Q.
Inside the Gaussian surface is Q. The charge on this sphere, we are taking the red sphere as the Gaussian surface.
Okay.
Now we apply Gauss's law. Right? That's what we have got. Apply Gauss's law. That's your Gauss's law. Right? Replace the flux there with your that value. Total charge is Q. Then there's your epsilon naught. And take it across there. That's what we get.
Oh, I need more practice.
No, these are new concepts. You have to learn to accept that. We are applying Gauss's law, that's all. So this is a new law that you have learned. You have to learn how to apply it.
How is it when you do so much of exercises, but then like after that you forget so fast one? How come like that? SPM like easy, but then STPM so hard.
You
Like I have
never do
to,
exercise. You do selected one, that's your problem. You do
so I
it,
have
you
to
will
try
force it in.
everything.
You do it, you will force it in. Just like definition in your English. You study English, you have to learn the new meaning of it. You need to know how to apply it. So you keep on doing it, that's how you remember it. So physics is the same. You don't keep on using it, you forget it. Your weakness is because you don't make the effort to learn. Don't know what you do with your time. No choice one. Physics is not like chemistry or biology where you can study one. It's just like maths. You don't study, you won't get good results. It's not something you can study. It's something that you learn from your teacher or learn from a textbook, and you have to apply doing exercise.
Okay.
Okay. So that is the formula we get for the electric field outside the spherical conducting surface. That's for a distance r away. And we know that the field strength is the same distance away, the same. Along all the sphere, electric field strength is the same value. So on the surface of the sphere, this sphere, conducting sphere R, radius R, then we just replace that small r with the big R. Right? So that the electric field strength at the surface of the sphere, this outside the sphere. Then we must know how to draw electric field inside the sphere, 0. Electric field outside, right? It decreases. Yep.
Radius increases, but the electric field strength decreases.
Okay.
Actually, the small r and the big R, what do they indicate? That means which one is
Big
the
R
one
is the
higher, which one is
radius.
below?
Big R is the radius of the charge sphere. Small r is the distance from the center of the sphere.
Distance from the center. Okay.
Right? So if you are asked to sketch it properly, you are given that at your surface is E naught. And how to sketch it properly? You just use this formula. Right? Take your ER square across, there is your constant. So at the surface, it becomes E naught R square. Then you can calculate for your value of E at a distance R away. Yeah. So at the surface, that's what you are told to do. Take it as E naught. Right? So that's the first one. The second one, put your 2R inside here. So it becomes a quarter. Right? A quarter. Yeah, a quarter here. Right? There's your E naught. 8 square. Half is 4 square. A quarter is 2 square. So draw a point there. Same. 3R. So it's E naught over 9. Right? E naught over 8 is here. Over 9 is slightly lower. That's if they require to sketch properly. Then a quarter is 16. 16 is just half of that, which is here. Then sketch your graph. Okay with that?
Okay.
Yeah, if you're required to draw carefully, like if they give you a graph paper, if not, you just draw the curve like previously. Yep, okay with that?
Okay.
No choice, you have to go back and review it. Right? Uniformly charged plate. Right? Inside there, remember, a plate outside there is positive charge. Usually you won't worry about the side there because it's too thin. Right? Thin plate there. Inside there, electric field is 0. The charge must appear on the outside because that's where they are furthest from each other. right? So let the total charge be Q and the surface area be S. So we introduce another term, surface charge density. So it's Q over S. S is the surface area. Q is the charge on the surface. Total charge inside the plate. As I said, they repel each other, so they will appear on the surface. Okay with that? You can go and review. Just accept it. Uniformly charged plate, charge density Q over S. Right? Remember, the charge on the surface is uniformly distributed because the charge repel each other. So on the surface, they can be as far away from each other as possible. Electric field line in this case are perpendicular to the surface. Right? It come out from the charge there. Each charge have a field line. So in this case, it's better to take a rectangle or a cylinder, either one. Here we choose a Gaussian surface as a cylinder, as the electric field is perpendicular to the surface. This surface there. Right? That's your side there. Right? So the flux on the side there, right, is 0 because your E is parallel to this surface there. So the flux is 0. But there is one coming out here. There's one coming out the other side. So your total flux is EA plus EA equals to 2EA. Applying Gauss's law, that's your Gauss's law. Okay, that's what we get. So place this flux there, is 2EA here. Then we get our equation. Okay, that one.